Hi, Victor Morganti here from FactEngine. I'm going to be giving a demonstration of object role modeling being used in the aerospace industry, and this video is the second part of a larger video on object role modeling and the aerospace industry as a whole, but I will publish it separately so that anybody who wants to jump straight into object role modeling being used in practice can come directly to this video. And it's a bit, it'll be short, it'll be at least half the length of the fuller video. So again, I'm Victor Morganti. I'm the author of the Boston Conceptual Modeling Software and the manager of FactEngine, and where Boston is object role modeling software. And some background, Boston's about 15 years old now, so it started in earnest in 2007, and my background with object role modeling dates back to 1993 with the predecessor of object role modeling, NIAM, so 29 years history and experience to date. So that's where I'm coming from, and as I give this demonstration of the use of object role modeling in the aerospace industry. You'll see me look down at my keyboard every now and then because I might need to pause the video to collect my thoughts and catch my breath, because I'm going to try and do this video in one take. It's going to be a mind-bendingly difficult video to make, but I think you'll get a decent understanding of how object role modeling is being used currently in the aerospace industry by the end of the video. We're going to be looking at an object role model, or a conceptual model, that ranges over a universe of discourse, so the subject area around the storage and production of telemetry data for satellites or space systems, and where the object role model that I'll be showing you is provided kindly to us by the European Space Agency. As you can imagine, when ESA is responsible for the ultimate delivery of space systems, or project managing over the delivery of those systems, the systems need to be built right the first time. And so ESA have selected object role modeling as a key methodology going forward with the delivery of specifications for space systems, and where at a broader scale ESA have adopted the principles of using MBSE, model-based systems engineering, where there will be going forward a larger emphasis of using models and conceptual models in the development of space systems. So that's always been there, undoubtedly. But over the last couple of years, MBSE has played a more serious role within ESA and ESA's member states and the suppliers who do business with ESA. Of course, there are other methodologies that are used by companies that provide services to ESA, such as the Unified Modeling Language, etc. And while object role modeling has been selected as a key technology, it's certainly not the only technology or methodology that's being used. And enough to say, for the purposes of this video, is that some key players within the industry have elected for object role modeling to have a broader focus and a more emphasized focus, and we can do some fact checking on that by looking at a key piece of work that ESA have been undertaking. So I'll just zip over to Google for a second, and we've got a Google search here, and we've searched for ESA, so European Space Agency Space System Ontology, and if I click on the first result there, we can see where ESA have put in place a program where they're developing a space system ontology, which is an ontology that enables the semantic interoperability between entities, so agencies and industry, along the life cycle of a space system. It addresses the system aspects of any space system. So ESA are putting together a global ontology for space systems, which can be reused selectively on various projects and programs that they're engaged with. Now, if you scroll down on this page, you can see that object role modeling is selected as the best technical solution to develop the space system ontology. So that's a fairly good endorsement for object role modeling as a methodology within the aerospace industry. So I'll be giving an example of a model that has been developed using object role modeling at ESA, and where again that's been provided to us kindly by ESA. The conceptual model we're going to be looking at is the model for telemetry and telecommand packet utilization, and as developed as a standard under the European Corporation for Space Standardization. The primary documentation comes under the prefix ECSS-EST 70-41. This is a June 2014 version I've got open here of the standard, and there may be newer versions of this document, but this document was going to be good enough for our presentation today. You can see, or you might not be able to see, but there's 631 pages in this document. So it's quite a detailed specification, and it's for telemetry or the management of telemetry data in space systems. So for those uninitiated, I've just done a quick Bing search on what is telemetry data, and we'll just read that very quickly. So telemetry data is the data that describes the performance, state and measurement of remote and hard to reach sources. So satellites are certainly hard to reach resources. So telemetry data provides information generally back to a ground-based system of the status of the spacecraft. So you can imagine that any satellite would need telemetry data for the ongoing maintenance, support and operation of that spacecraft. So I'll just read out a little bit of the description of the standard, and where it says this standard addresses the utilization of telecommand packets and telemetry packets for the purposes of remote monitoring of control of spacecraft subsystems and payloads. This standard does not address mission-specific payload data packets, but the rules contained herein can be extended to suit the requirements of any mission. So I'll just leave the description as that for now. If you search for the ECSS-E-ST-70-41 documentation, you'll find this standard. It's not a classified standard by any means, and this much is publicly available. Down the bottom you can click on a link to get the PDF. You will need permission to get the PDF, but if you search around, it is online, and not a classified document. So this 631 page document is pretty much all about conceptual modelling or data modelling for telecommand packets, so packets of information that are stored and sent from satellites, generally back down to Earth or a ground-based system, for the monitoring of the spacecraft. Now, why I've introduced you to the documentation up front is because earlier in our fuller video on this topic, we were looking at where object role modelling can be used to provide a semantic view over data structures, as depicted here by, say, database platters here. Now, object role modelling is a type of semantic modelling or conceptual modelling that is semantically verbose, and I would argue that it's the most semantically verbose conceptual modelling language in the world. It consists of two primary parts, so a diagrammatic part, and so a graphical notation, and a natural language notation, and it can be used to produce documentation and to be able to communicate models, which is very important under the model-based systems engineering ethos, and for the design, test, implementation and ongoing operation of systems where object role modelling is used to design the data structures used by those systems. And the overall picture is that we're going to be looking at where object role modelling is used to design and document data structures for telemetry data. So this picture represents telemetry data being beamed down to Earth, to ground-based systems from satellites, and where operational staff, say this lady sitting in front of computer systems with, say, telemetry data being monitored, and also, of course, the engineers who work on building the satellites need for the models to be highly accurate, concise, descriptive, and uniformly utile in terms of being able to accurately describe what's required for the ongoing operation of the spacecraft. So let's get straight into it. I've got the Boston conceptual modelling software open in front of me, and I've got a model open in the Model Explorer, which is for the telemetry and telecommand standard. Now, it consists of a whole suite of pages. These are pages within the model, and where I can open up particular pages and view them as under the graphical notation of object role modelling. So this is an object role model, and this forms the graphical notation of object role modelling. Pages in Boston show various sections of the overall model, and where we can have notes within the model to help describe the conceptual model. and where under a model dictionary we can see not only all of the object types within the object role model, and between object types, fact types, some of which might be objectified as an object type, and constraints. In this particular model there's 2,601 model elements within the model, so it's quite a large model. In fact, it's I would say it's massive. So in Boston you get to see the conceptual model as an object role model, but also as an entity relationship diagram. We'll just have a look at a section of the model as an entity relationship diagram there, but also in Boston as a property graph schema as well. So this is a property graph schema where we can see properties of node types. So we can view our model as a property graph schema or a entity relationship diagram, or as a whole suite of object role models. Now in the entity relationship diagram view, there's, I don't know if you can see it on your screen, but there's 293 tables in this model, which if this model was developed as a single database, it would be a massive database. So 293 different tables in the database. And we can have a look at, say, the address data entity or table, and where it has a primary key of address data hash and has an address type and hardware address, etc. But what we're most interested in here today is the semantic modeling component of object role modeling, which makes it so attractive to organizations such as ESA. If I right click on the model and view a glossary, I can see my hundreds to thousands of object types in a glossary, and if I select a particular element in the glossary, and I'm going to find an element that I know is there called service type, and click on that term or object type within the glossary, I get in natural language a broader description of the business rules that apply to that model element within the model in natural language. So I can see where a service type is one mission specific service type, and a service type is one request verification service type, and a service type possibly is type of, or is more than one type of service. Now already I might be going a little bit fast for you, because you might be scratching your head thinking, well, what's a service type? What does it mean in the scheme of things, etc. Now I'd argue that's exactly how these people feel when they first join a team to work on a project within the aerospace industry, especially if they've never worked in the aerospace industry before. So the internal customers for our conceptual model is definitely the people who work in the industry and who need to be able to communicate models with each other. And where they need to be able to understand the terminology within the industry. So object role modeling helps with that, and object role modeling tools help with that by being able to navigate around the model very easily, especially inside Boston, and where natural language constructs help us to form a view of our model. Now, I don't want to give a lesson on object role modeling here today, but if I go back to this page where there is service type on that page, and where service type has a unary fact type that reads service type can demand that all subservice providers are hosted by a single application process. What we're doing there in our object role model is effectively establishing a Boolean attribute at the entity relationship diagram view, where we're saying true or false whether or not a service type can demand that all subservice providers are hosted by a single application process. And we're not just saying an attribute name true or false, we're actually giving quite a lengthy description of what that Boolean value is about. Similarly, with relationships between object types, say a service type and its subservice type, or a subservice type, we can read where a service type defines a subservice type, and a subservice type is defined within a service type. Going back to the glossary view, I can narrow down on my descriptions if I want to find more information about the relationship between subservice type and service type. And where I've found that particular fact type that has that definition that we were just looking at. So each subservice type defines more than one subservice type, and a subservice type is defined within a service type. If I then wanted to find out more information about a subservice type, I could click on SubserviceType type and go to its set of business rules or description, and where, if I need to, I can use this tool as a means of providing documentation. And object role modeling has certainly been used to provide documentation, because the model that I've imported into Boston to give this demonstration was developed in the Norma software. And if I go over to Norma now, I can look at, for instance, the same page 532, where I've got service type and subservice type, and where this is the same object role model but color coded for various reasons that ESA needs, and where from the Norma tool the documentation in the PDF has been developed. So if I go to the PDF for the telemetry and telecommand packets standard, and I go to 532, and where we're looking at a page within our model which has been conveniently called 532, and where we're talking about service types and subservice types, I can go to that section of this document and I can tell you that this documentation here has been developed pretty much automatically from the object role model. and where the set of business rules or engineering specification, in this case, in this document, have come from the object role model. So for instance, where it reads, each service type shall define at least one subservice type, that's what we have in our glossary for service type, and where we've narrowed that down to the relationship between service type and subservice type. So each service type defines more than one subservice type. And where here it reads, each service type shall define at least one subservice type. So this verbose documentation, so the system specification, has been drawn directly from the verbose natural language within our object role model. And object role modeling gives us lots of tools to work with. So if I go back to the object role model, these circles here are constraints. And where, for instance, if I click on this constraint, I can read its natural language verbalization, which forms the secondary component of an object role model, and where that constraint reads, for each subservice type, exactly one of the following holds. That standard subservice type is some subservice type. That mission-specific subservice type is some subservice type. So only one of those holds. So of the subtypes of a subservice type, it can be either or, but not both of those subtypes. Now in our glossary view, if I look at subservice type, and look at its constraints, here are our constraints in natural language. Now what we can do, because we're more or less looking at a web page there, is if we're working, say, with a Microsoft Word document, we can copy those natural language constraints directly into a Word document. And in the web-based version of Boston, I can get all of that in black and white, in just plain text, to be able to copy over to any documentation that I'm creating. And that natural language verbalization or extrapolation of our business rules or our engineering specification comes directly from the object role model. We also have the ability to, within the glossary view in Boston, to view for whatever we're looking at, in this case the service type or subservice type, the diagram or diagrammatic notation that surrounds subservice type. Now that's a bit of a busy diagram, but with object role modeling tools, what you can do is jump between views to different pages to navigate around the model. So we're just opening another page that shows subservice type. So there's subservice type on a different page within the model. So we have a graphical notation view of our model, we can have model notes in natural language. Because we're using object role modeling, we can extrapolate the model into natural language so that it's easy for people to understand. And where, in this instance, what I've done personally to try and understand the model is that I've navigated around the glossary to try and understand what a service type and a subservice type is. And I can tell you. So let me go back to my slideshow, and where if we're a satellite and we're orbiting around the Earth, and where there are various sensors on the satellite, and where those various sensors collect data, what happens is within a satellite is that, for instance, if these blue disk placards here represent the data store of various sensors, those various sensors provide the satellite, conceptualized by, say, a centralized data store, with the telemetry data via a set of services. So it's almost as if the satellite has a service bus and a network within its architecture to be able to channel, amalgamate and send packet data back to ground-based systems over a quasi-service bus. Now let's see if we can navigate around the model to actually do that, to form that view in our mind as we try to understand the model, which is, you know, a large model with over 2,000 model elements. Well, we know we're talking about packets of data, so let's start there. Let's type in packet in the glossary. And these are the various model elements that have got packet in the name somewhere. And we know we're sending packets of information back down to ground-based systems. Now, if I look at, say, a packet store, what does that tell me? Well, let's have a look through and see what we can find. So a packet store transmits its packets over one virtual channel. So we can imagine a channel from the satellite down to Earth. So let's click on that and have a look at that. Here we go, we've found something. So a virtual channel can be used by a storage and retrieval subservice. So we're getting close to our service type, so let's click on that. A storage and retrieval subservice is one subservice. So let's have a look at subservice. Here we go, this looks interesting. A subservice possibly contain more than one message. Now, packets are messages that are being sent down to Earth to a ground station, so that sounds good. Let's have a look at message. A message is a report. That sounds like telemetry packet data. Let's click on report. and where a report is addressed to one subservice user. Let's have a look at subservice user. And each subservice user belongs to one subservice. And each subservice is of one subservice type. So we've found our way to a subservice type. So we're finding our way back to this diagram here. So you can use the glossary view to navigate around the model. If I go back to this particular page within the model, there's a model note here that something inside this model is to support the PUS and some numbers there. So what's PUS? Now I don't have an expert from the aerospace industry with me, so I'm just going to do a generalized internet search, and I'm going to do that via using ChatGPT, which has its artificial intelligence model based on what's on the internet. And let's do a search about what is a PUS. So what is a PUS in relation to telemetry command? Let's see what ChatGPT says about that. In the context of telemetry command, the term PUS stands for Packet Utilization Standard. PUS is a standard developed by the European Corporation for Space Standardization for defining the structure and content of telecommand and telemetry packets used in space missions. So that sounds like it's accurate. Of course, you can't trust everything from ChatGPT, but this sounds pretty much spot on. If we look at our model and go back to our glossary, perhaps there's something within the glossary on PUS. And sure enough, there's a few model elements within our model. Let's click on PUS packet type. Or even better, PUS standard. Now, what we can do inside Boston is we can view our model element, its properties, and we've got a long description and short description field. If I'm happy enough with that description, I can store that in our short description field. Re-click on PUS standard, and now I've got a short description in natural language in our glossary view. And if I select the PUS standard within, say, the model dictionary, which is a different view again of the model, there's a description toolbox down here where I've got a short description. I can also store a long description. And then from within the glossary view, when I'm searching through my glossary, I shouldn't have to guess what all these terms mean. If someone goes ahead and actually puts the informal descriptions against the model element itself. So in terms of model-based system engineering, which really stresses the ability to be able to share models between tools. This model has been imported from Norma, and we've enhanced the model by providing an informal description, and where we could share that somehow back with Norma, because if I go to Norma, I can probably look up PUS standard inside the Norma tool, and there's its properties there, and it's got a field for informal description. So we can share an informal description back with Norma, which fits nicely with model-based systems in engineering, where we've got two tools that use object role modeling with similar functionality, and where we can enhance the model in one tool and share it with another tool. And I can tell you, as the author of Boston, we're working on ways to export object role models from Boston to Norma. That's already in beta, and we want the ability to completely export a model that can be imported back into Norma. So let's go back to Boston for a second. And talk more about model-based systems engineering. Now, the reason why MBSE is important to the likes of ESA is that not every tool has every feature. So Norma doesn't support a glossary view the same way that Boston does. So people might be able to do work in Boston that they can't do in Norma. And there's certainly things in Norma that you just can't do in Boston at this stage as well. So by creating a bigger pie where various tools can take on a different load across the spectrum of requirements for tools in the conceptual modeling space, by adopting MBSE and really entrenching an ethos where we're saying, if we want MBSE to work, tools need to be able to talk with each other. From my perspective, that works well for me, because it just creates a bigger pie. It creates a bigger pie for object role modeling. It creates a bigger pie for the Boston conceptual modeling software and Norma, and where ultimately customers get the ultimate benefit. Because if we're these staff developing space systems, we can get to know our model a lot better, a lot quicker, if we have the right tools. And I'd argue natural language tools are the best way to achieve that aim, to be able to come up to speed as quickly as possible with the terminology. Not only that, we want to reduce the ability for there being ambiguous definitions on the structure of data structures defined by our models, and arguably object role modeling provides the best methods to do that. So where else can object role modeling be used in the aerospace industry? So let's just recap where we are first. We've seen where object role modeling can provide the ability to define our conceptual schema or conceptual model, and communicate that model, and most certainly document a model, and where, as a semantic view over data structures, it provides the ability to understand those models a lot easier as well. But there's more to the semantic view. that is made possible by object role modeling, and we'll just have a quick look at that. If I go back to Boston and step away from the telemetry model for a second and just quickly have a look at the Northwind model, the famous Northwind database by Microsoft. We know that in Boston, because we use object role modeling, it's easy for us to view our model as a property graph schema or an entity relationship diagram or a suite of object role models and variously morph between them. What we get out of object role modeling is that the predicates that are formed by constructing our object role model give us these predicates in this quasi Barker-ER diagram here. So it's not Barker diagrams in Norma are Barker. They're stylized Barker diagrams or ER diagrams in Boston. We have the ability to view our model as a property graph schema with the same underlying object role model, and I've got lots of videos on that on the Fact Engine channel on YouTube. When we have a property graph schema, we can write queries against databases using a graph language, and where probably the best graph language on earth is natural language. So Fact Engine exploits object role modeling to be able to do things like this. We can say which employee took an order that is for a product that is supplied by a supplier that is based in the USA. So there's a natural language query or controlled natural language query, and it's a graph query. There's a database behind this conceptual model, and if I hit go on that, it's going to return results. So here's our results from our query. But more than that, we can do business intelligence queries in straight natural language if we hook our model up to a large language model, so use artificial intelligence to convert natural language to controlled natural language to get our results. So I can ask the same question. I can say show me employees that took an order for, now I'm just going to write it loosely, so products supplied by suppliers based in the USA, and hit go on that. Now, if I'm lucky, that's going to translate to more or less the same controlled natural language query and give us our results. So we've got the same results, we've got the same natural language query and controlled natural language, and it's been converted to SQL in this case, and that's all made possible because of object role modeling. Now, that's fine for a relational database, but we live in a modern world where we have graph databases, so I'm going to run the same query against the same model but with a Neo4j database in the background. I'm going to hit go on that. If I'm lucky, I'll get the same results, but this time my query is in Cypher. So it's a graph query in Cypher for Neo4j. So we've used the same controlled natural language query to do business intelligence on our database, where we can variably generate queries in Cypher or SQL, and where you can imagine that if we had a database for our telemetry model with 293 tables, it would come in very handy to do business intelligence queries in controlled natural language or even natural language against a database behind the telemetry model, especially for development and testing of the software and hardware systems. If there's a database that say replicates or mimics the onboard systems on the satellite, then you can do your development testing and ad hoc queries using tools such as Boston to be able to do that, and that's all made possible because of object role modeling. So all these predicates in our natural language queries come about because we're using object role modeling. So it's not only in development, but obviously then when we start to get user data back from our satellite systems, we can do business intelligence queries against that data as it's returned from the satellites in natural language. So let's wrap it up there, because we've got a lot of videos on YouTube about object role modeling, especially on the Fact Engine channel, where today we've introduced where object role modeling, which is very much a known commodity in the year 2023, we've seen where object role modeling can provide a semantic view over databases, or a semantic view over the data structures, say on our satellite systems, so our telemetry management systems on board satellites, etc. The semantic view of object role modeling is because it's a verbose conceptual modeling language that incorporates semantics at a high level with natural language, and where object role modeling has a graphical notation and the natural language notation, and where documentation can be automatically generated from object role models, and where we can communicate amongst ourselves to be able to understand our models. And not only amongst people, but you can use, say, exported object role models as XML, for instance, to share models between computer systems, and especially modeling systems like Boston and Norma. And we can use object role modeling to do our design component for the data structures of our various software, and even when it comes down to the data on hardware, it can be designed using object role modeling, the structure of that data. So let's go backwards. We looked at telemetry data being beamed down to Earth, and where the telemetry packet information was defined using object role modeling in the aerospace industry, and where our internal customers are very important as much as our external customers, and where the internal customers in the aerospace industry are the people who operationally look after satellite systems, for instance, and those engineers who design and build the hardware for our space systems. We've got a methodology which is custom built for sharing models amongst people using a tool that's been with us for thousands of years, and that's natural language, and where it's not just sharing information between people, it's also sharing information between computer systems and the modelling systems that are used to define our systems in the first place. Where we have the semantics of business vocabulary and business rules offered by object role modelling, which takes us well beyond where we used to be with just entity relationship diagrams in object role modelling, and where we're implementing model-based systems engineering by having various object role modelling tools in the aerospace industry already for our internal customers, providing that man-machine interface, or even the ability to communicate amongst ourselves in an industry, and the systems used within the industry, so not just people, but data exchange between information systems as well. Where, for instance, our external customers, such as people using a online video chat software, get the benefits of having systems that are operational 24/7 and are built with quality and made to last, because we just can't fly up to space and fix a satellite if we don't get it right the first time. Not that easily. Ultimately, it's about happy customers, both internal and external. And in the aerospace industry, we're doing that by designing our systems efficiently, elegantly, and with a high degree of quality up front. And that's object role modelling in the aerospace industry. Is there more? Yeah, there's more. So I can just show you a couple of other things very quickly. If we go back to Boston, I'm now looking at Boston inside a web browser, and where we can do collaborative conceptual modelling over the internet and via geographically displaced users. So you can have someone in Scotland working with someone in France, for instance, on the same model over the internet, and where you can have user access control over who has access to various models, what they can do within a model, and where we have things like projects, users, roles, groups, roles and permissions, and where the European Space Agency had a project a few years ago called Famous and Famous 2, which specified how that should be set up for fact-based modelling tools. So this is in a browser. If I hit F11, for instance, in the address bar, that maximizes, and all of a sudden I've got a full version of Boston inside a web browser. So that might be handy, and that's object role modelling for the aerospace industry, because especially with ESA, you've got member states and ESA members, so companies providing services to ESA that are geographically located all over Europe. There's also in Boston, ever so briefly, the ability to do use case diagrams, where, for instance, we might set up an ACTA ground control system, and where for telemetry, the ground control system initializes communication with the satellite, sends telemetry packet request, receives telemetry data and processes and displays telemetry data back to the user. And of course you could extrapolate that out into a fully blown use case diagram. So with model-based system engineering, that is important to some people, that there's at least some element of crossover between object role modeling and the UML and other languages. So Fact Engine at least is heading in that direction where that's going to be possible. And also Boston supports state transition diagrams, where I've picked on one particular value type within our model, the OBCP execution status, where OBCP stands for onboard control process, I believe, for the telemetry system, and where I found that in the glossary by doing a search on status, and I found a few model elements with status in the name, and where object role modeling you can have value constraints where OBCP execution status is restricted to inactive, active and running, or active and held. Don't take my word on this, because I don't know the transitions between those various states, so I've actually just made this up. So we go from inactive to active and running, maybe back to inactive, or maybe from active and running over to active and held, or back again and then back to inactive. Maybe there is no real end. You know, you could probably end on any of those. So, and we could make our state transition diagram like this. So that's in Boston. It's not exactly object role modeling, but certainly if we're storing information such as the various states or values that you can have for a value type, then certainly when it comes to a value type that holds values for a status, you can envisage where state transition diagrams come in very handy. So that's a future direction for object role modeling, and as it relates to the aerospace industry. So thanks for watching. I hope you enjoyed the video. If you like the video, please hit like and subscribe, and I'll see you in the next video.